Camera audio.
I actually don't know where that audio is. I think it's coming from this.
Oh, yeah, it's done.
Okay. It's kind of noisy, but my AirPods. I can listen to that with my AirPods.
Actually, I've said definitely zero. Or is that, never mind, you probably got it.
Yeah. Sometimes Apple stuff works. Okay. If you're ready, I'm ready. Ready? Okay.
Excellent work there. I love it.
I assume we're getting audio.
All right. Hello, everyone.
Hello.
How are y'all doing?
Good.
Surprisingly, that response was better than the one I got on Wednesday at the general meeting. No, I get but I love the enthusiasm, guys. All right. So in case you're unfamiliar, we're using Slido. It's basically an online Q&A. So if you'd like to go into the room, it's going to be called #Frost, and you can ask any questions that would be asked at the end, especially in particular for people that you get today. Member dues, if you haven't paid yet, there's two ways to do it. You can pay online at acm-dtsa.org/join, and you can also scan that QR code right there. Or if you'd like to pay in cash, you can pay Lauren Doe. She's sitting there in front, and she'll take your money. Slack, I think everybody in here is probably familiar at this point, but this is our workspace. 3 ways to get on it. You can pay online, you can pay in cash, or ask an officer, and we'll get you hooked up on that. In Slack, there's a few channels I know everyone isn't a part of quite yet, so I just wanted to announce them. Hackathons, careers, and opportunities. So there's some great places to get some specific information that you might post outside of, We have a lot of social media. We have a YouTube channel, which is currently streaming. Instagram, Twitter, Facebook, LinkedIn. Make sure that you follow us because we just want you to be our friend. Loyalty points. So for every ACM and ACMW general meeting that you go to, any workshops or events that we have like that, that's going to be 1 point. Any larger events like Rowdy Hacks or the CS Picnic, anything that we announce as like a major event, that's 2 points. So at the end of the semester, if you have 20 points and you're returning next year, you'll get your membership fee waived. If you are graduating this semester, then you'll get ACM Stole. And right now we're piloting something pretty new we're excited about. So if you scan this QR code right now, you can actually see what your points are. So if you're curious to see like how many points I have right now and if I'm going to be able to make it, definitely check that out. I'll give you like 4 seconds to scan that if you haven't already. And shirts, if you're a due paying member and you haven't picked up your shirt yet, just let us know. We don't have them with us right now, but we can definitely hook you up. Just come up to us after the meeting. All right, some upcoming events. Rowdy Traders is tomorrow at 10 a.m. It's going to be in Hidalgo. So if you're not familiar with Rowdy Traders, it's kind of like our incubator. If you'd like to start working on a project that's a little bit more long-term and a little bit more collaborative, I would definitely recommend checking out the meeting. ICDC is meeting tomorrow at 10, or Saturday at 10 a.m. That's in the 4th floor activity room. I would definitely recommend checking this out, especially if you're trying to brush up on some algorithms and data structure. After we return from spring break, well, 30 spring break, Monday, March 16th at 1 p.m., we'll be doing an underclassmen meeting on expanding your dev environment on Git. So if you're an underclassman and you have no exposure to Git so far, you haven't done any of your classes, I would definitely recommend this because it's a great way to start getting a little bit of a leg up on something that you're definitely going to need a lot of experience with in your academic and professional careers. So I would check out that meeting. Our general meeting on March 18th, which is Wednesday time, 1 p.m. is in Mesquite. We'll be talking about cloud infrastructure that's powering Rowdy Hacks. Just Rope is actually in the background now. He's going to be giving that talk. If you have any interest in cloud or networking or anything like that, go check it out. And Rowdy Hacks, March 28th and 29th here in the HEB Student Union, 100% free. Do you have to be a seasoned programmer to attend this event? No, we do not. We're looking for all skill levels and backgrounds. So if you haven't applied already, make sure to go to www.rowdyhacks.io and follow us on social media. And without further ado, we have Frost with us today. They're going to be talking about some API security, so let's give it up for them.
Good evening, everyone. My name is Vipul Gupta. I haven't spoken in a classroom in a long time, so bear with me. I'm really excited to be in front of you all, sharp people. So let's make this session as interactive as possible. Before I get into the material, I want to give a shout out to a few of my colleagues that are here joining me today. Eddie Contreras is the Chief Information Security Officer of Frost. Xavier Jimenez and Ben Bravo, they are both UTSA graduates and they are currently working on my team as application security analysts. I also wanted to point out that Xavier helped me with these slides, so I wanted to give him credit. All right, let's get started. I am Vipul. I've been with Frost for about 7 years, and I currently work as the application security manager. I started the application security program at Frost in 2013. Before I started with the abstract program, Frost was doing some static and dynamic analysis. When they brought me on board, my job was to establish more formal processes regarding application security and expand what we were currently doing. I have a master's in engineering, in computer science and engineering, with focus on information security and assurance from University of South Carolina. I don't expect any Gamecock fans here, but I'm a Gamecock fan. I have a CISSP and a CSSLP certification, and over 9 years in application security, and 13 years overall in information security. So this topic is about OWASP API Security Top 10. So let's talk about what OWASP is. Without Googling, can anybody tell me what OWASP stands for?
Security principles?
Almost right. It stands for Open Web Application Security Project. It was created in 2001 with the sole purpose of raising awareness to web application security. Back then, nobody was worried about mobile app security. Nobody was concerned about API security. Back then, everybody was concerned about web application security. So a group of people got together and founded this OWASP Foundation to create documents that they would make freely available so that the industry would get more asset aware. So some of their key publications, I'm not going to go into details on these, but I want you to point out that they do have a top 10, which is commonly called OWASP top 10 for the web applications. They also have a mobile top 10 and the API security top 10, which I'm going to talk about today. The web top 10 was created in 2003 by Dave Vickers. I work very closely with him. He's a good friend of mine, so I got to learn a lot of cool stuff from some of the OWASP founders, which I'm really proud of. They have the software assurance maturity model, which is called SAM. It used to be called Open SAM. Now it's called OWASP SAM. What this is used for is to evaluate this maturity of a software security program, an application security program. It is very much in line with the building security in maturity model that Gary McGraw made from Citadel. It used to be Citadel, now it's Synopsys. So these two models are very similar to each other. This one is more on the open format, so you are free to just download this and start using it. You can download BSIM for free also, but in order to get a BSIM assessment done, you have to pay for that. Development guide, OWASP has a development guide for people that want to build secure applications. And then they have a testing guide, which I highly recommend if you want to get into security testing, penetration testing, or any kind of security testing. This is a wonderful guide that teaches a little bit about how to test for common security vulnerabilities. Then application security verification standard. It's used mainly by auditors to evaluate the strength of security controls in an application. So you can assign a rating of level 1, 2, or 3, and then that's how you can evaluate how strong the control is. And there's many more. These are just a few that I want to get done. So now we are going to talk about API. Without Googling, can somebody tell me what API stands for? Yes, please.
Application programming interface.
Perfect, yes. API stands for Application Programming Interface. It's an interface or a communication contract between a client or a server. The whole purpose is to make sure that the client knows how to communicate with the server and how to understand what the server is saying. So a predictably formatted request will give you a predictably formatted response. APIs simplify programming by hiding all the implementation details. All a developer needs to know is how to utilize an API endpoint. And APIs enable application written in one programming language to utilize components that are written in other programming languages. So it really makes reusing components easy, regardless of the platform. So where is an API used? It's used everywhere. It's used in single page applications, mobile applications, business-to-business communications, cloud, Internet of Things, etc. Almost all modern applications use APIs. So let's talk about how a modern application is different from a traditional application. In a traditional application, we have a client, a browser, that sends a GET request to the server. Server does some processing. If data is needed from the database, the server gets it, does all the processing on the data, and sends it back to the client, the web browser, for rendering. In a modern application, multiple API GET requests are sent to the servers, and then server can, if the server needs any data from the database, gets that data. But the main difference is that in a modern application, raw data is sent back to the client, and it's up to the client to do the rendering of that data. And we'll talk about why that could be a problem when we go into the API security of that. So I want to talk a little bit about the process that was followed by the people that came up with the API top 10. So in the first phase, they researched publicly available information on security incidents that had happened because of API security flaws. They did not get a lot of data because a lot of companies don't disclose exactly why something failed, why something was breached. So what they did next was they reached out to the security practitioners in the industry that do pen testing to get their opinion on what are the top 10 issues with APIs. And then they combined those two lists to come up with, to have a consensus between these two. And then in May of 2019, the first draft of OWASP API Security Top 10 was presented in Global AppSec Tel Aviv. The version 1.0 was released on December 31st, 2019, so this is very new. So now let's get into the API Security Top 10. The first one is API 1 is broken object level authorization. So can anybody tell me the difference between authentication and authorization? Yes, please.
Authentication is like finding who you, making sure you're the person you say you are. Authorization is like determining whether you have access to a file or not.
Exactly. So this one is going to focus on authorization. So APIs tend to expose more endpoints that handle object identifiers. So in a normal use case, the developer will expose an API endpoint, and the input to that endpoint would be an object identifier. Based on that object identifier, access to that resource is provided. So in this example, I know it's hard to read, but the user X wants to access a document that belongs to user X with an identifier of 1000. So that's part of the request. I apologize, it's too small, but here it's passing the object identifier. What if there was a user Y with object identifier of 1002 and the user X was to ask for it? With the broken object level authorization, user X would be able to read a document they should not. I want to point out this is the biggest problem with using APIs. It's the number one issue. So broken object level authorization is a big problem. So this is an example, real world example of Uber. Uber had this vulnerability disclosed by this researcher called Anand Prakash. He does this for a living. He works on bug bounties. So what he did was, he was able to find an endpoint that Uber was exposing where you could provide a phone number or an email address. And when you provided that, the response would contain a universally unique identifier for that user. There was another endpoint that was exposed where you could provide that UUID as an input, and then it would give you all the information about that user, including their access token. Once you have the access token, you have full account takeover. So you could potentially take over anybody's Uber account using this flaw. Uber did fix the issue, I think, in 1 day of notifying this, and so how they fixed it is by authorizing the request with the current user session. So you would only be able to make the request for your own account. And more importantly, they removed the sensitive information like the access token from the response. It should not have been there in the first place. So how do we prevent broken object level authorization? Before giving access to any resource, make sure the user should have that access. So confirm that the user is authorized. Best practices are prefer to use random GUIDs instead of sequential, because sequentials can be guessed and scripted. Write tests to evaluate the authorization mechanism. Test thoroughly. Do not rely on IDs sent from the client. All this validation, all the security decisions should be made on the server side. And leverage the AppSec team to evaluate if authorization is good enough. So I work for AppSec team, so I'm a huge proponent of leveraging AppSec team when you can. Any questions on API 1? All right. Yes?
So how often do you get reached out to by teams?
All the time, and they can attest to that. We have a lot of processes where we work very closely. We actually partner with them. They will reach out to us whenever they are trying to do something new. And so very early on, they engage our team, and we have a very good partnership. So broken authentication. So we talked about authorization. Now the second issue with the use of APIs is broken authentication. It's the same for web applications. Broken authentication is number 2 for web applications as well. So it's just, regardless of API, it's not an API specification. But we'll look at it from an API perspective. So authentication mechanisms are very difficult to implement correctly. I would recommend leverage standard frameworks. Do not try to create your own authentication mechanism. Broken authentication can allow an attacker to take over someone's account. Authentication endpoints need to have more protection. And what are authentication endpoints? They can be like login flow, your forget password, your reset password. A lot of times, developers will pay a lot of attention on the login flow, but they forget to pay the same scrutiny on the forget or reset password flows. So this example, this real-world example is for Facebook. Facebook had the same researcher that found the Uber finding also found the Facebook finding. I think for one of them he got $15,000 as a bounty, and for the other one he got $20,000 as a bounty. So he's pretty good at it. So Facebook allows the option of resetting your password by using an email address or a phone number. Once you provide an email address or a phone number, Facebook sends you a 5-digit code. The problem with the 5-digit code is it has only 100,000 options, so it's easy to brute force. So what he did was he tried to brute force on Facebook.com. He was locked out after 10 attempts. But when he tried the same thing on beta.facebook.com and mbasic.beta.facebook.com, he was able to reset password by just writing a script and going through all the options. And he was able to change the password, so essentially it is also an account takeover problem. So how do we prevent those? Enumerate all authentication flows. As a developer, we should know how a user would get into our application. That's very important. And it's equally important to understand what we are doing from an authentication perspective. Understand those flows. Are they really necessary? Leverage your AppSec team to do the analysis on those authentication flows to make sure that they are secure, that there's no security vulnerability, that security is applied throughout all of those authentication flows. Like not just the login flow, but also the forget password and reset password. Implement account lockups. As we saw that for Facebook.com, account lockup was in place, therefore he wasn't able to proceed with the brute force type attack. Rate limiting is good, and we'll talk a little bit more about it as we go further into the API series. Rate limiting is important because you need to prevent someone from just scripting an attack. You need to slow them down. Without Googling, can somebody tell me what CAPTCHA is? Can somebody tell me what it stands for? Okay, I'm going to give it a try. So it stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart. This is used for determining whether a user is an actual human or a computer or a bot. So it's good to implement CAPTCHAs so that you can prevent your application from automated attacks. Leverage multi-factor authentication. We should not be reliant solely on a single factor authentication anymore. So username passwords by themselves are not good enough. Disallow weak passwords. Follow industry standards. Leverage NIST. NIST has a really good guideline that they recently came up with that talks about what kind of passwords an application should have. Use password strength meters. So give users the opportunity to identify that they're using weak passwords. Allow them to select stronger passwords for their application. And one item that I forgot to include here is leverage password managers. API 3, it's excessive data exposure. So developers like to have generic implementation so they can reuse their code from one place to the other. So what they do is they expose all object properties without considering whether they're sensitive properties or not. Instead, they rely on the clients to make the determination and render whatever they think the client should render. Sensitive data might not be displayed to the client, but it is important to know that any data that is flowing between the client and server can be intercepted and the bad guy can view it if they can see that traffic. So in this case, there's a dating app. You can search for users, and the dating app will respond back with the name, the hobbies, the profile picture. What it's also sending, even though it's not being rendered, is the address of the user, which is not rendered, but somebody who intercepts the traffic is able to see that and find out where to find them. So this is a real world example. I chose not to include the name of the application, so I'm just calling it a dating app. You can search for users, and it will give you a response with a lot of the information about the user. The problem with this response is it includes the exact latitude and longitude of the user. That means you can really map them on the map. And so when they were doing this, they found some folks they were logging in from White House or whatever. So for a person trying to search for potential dates, they don't need to know their exact location. So, but the application did provide an option for the user to hide their latitude and longitude. The problem was they were still sending that data to the client, and they left it up to the client to not show that data. But again, as we saw, anybody intercepting that traffic will be able to see it. So how do we prevent it? Only return what is needed. Identify all sensitive and personally identifiable information and justify its use case. Even though a product owner may think that they need all this data, we need to question them, do you really need that data? And justify why you need that data. Never rely on the client side to perform sensitive data filtering. So always have the server do the filtering and send only what is needed to the client. Perform dynamic analysis of the application before releasing to production. So make sure you are doing all your security due diligence, all the testing before you release something like that to production. Any questions so far? All right, next is API 4, which is lack of resources and rate limiting. We talked about rate limiting a little bit earlier. So quite often, APIs don't care about limiting how many requests or the size of responses they are getting back. So why could that be a problem? There could be a denial of service attack, where a bad user could just bombard the server with a lot of requests, and the server is not able to process those requests, or crashes, or is unable to service. The other option with not limiting the rate or the number of requests is that someone can have a brute force attack. So in this example, the attacker is trying to brute force email accounts that have 1, 2, 3, 4, 5, 6 as a password. So it's just sending a bunch of email addresses and passwords. And now, as you can see in a minute, they start cracking these accounts. So that is why we need to have rate limiting, and the size limit on these requests. So how do we prevent them? Implement a limit on how often a client can call the API within a time frame. So if it's a login form, then how often should a user be able to log in within a certain time frame? If you suspect bot activity, slow them down. Whenever possible, enforce maximum size of data on all incoming parameters and payloads. It's not always easy to identify what that maximum payload would be. So in that case, you would have to work with your product owners, the lines of businesses, to ask them, what data are you expecting? What's the worst case data size that you might have? And then impose that limit so that there's an upper limit to the size. Next, we're going to talk about broken function level authorization. So as you can see, there's two authorization problems within the top 10, within the API top 10. So when we are using APIs, authorization is really a problem. So we need to pay extra attention. And why is authorization a problem? Because access control is very complicated. It's not easy. Right? It's difficult to implement. There can be a lot of different types of roles, hierarchies, groups within an application. And quite frankly, a lot of times, developers or lines of businesses don't take the effort to document all of them or understand all of them. So an unclear separation between administrative and regular functions can lead to authorization flaws. So I want to just take a moment here to explain the difference between API 1 and API 5. API 1 was about the objects. So it was a broken object level authorization. So if you're providing an object ID, just make sure the user should have access to it. This one focuses on the function. What is the function that the user should be allowed to perform? So in this example, Alice is an admin, and she can delete any user of her choosing. Now Bob, if Bob figures out the format of that request, can Bob make that malicious request to the admin API? With a broken function level authorization, Bob will be able to delete that user, as we know that Bob shouldn't be able to do it. So Shopify, this is a real world example. I had to find out what Shopify was. So it's an e-commerce platform that allows you to sell stuff online, in person, or on social media. So if you own a store, you can have business partners that can be collaborators to your site or your store. The issue with this one was that it was possible to be granted collaborator access without interacting with the store owner. So you could potentially have access to any store on Shopify. That was because the code was not checking whether the account that was asking for collaborator access actually belonged to that store. So they were just providing access if it was in some pending state. Shopify did fix the vulnerability by properly verifying the account that was making the request, just to confirm that this request for this account actually is from a store owner. So how do we prevent broken function level authorization? Enumerate and understand all roles and functions. So it is very important to take the time to enumerate, write them down, and understand what each role is going to do. Implement a strong authorization mechanism based on the role. Validate all the requests on the server side. And deny all access by default. Number 6 is mass assignment. So, due to in modern applications, because a lot of the functionality is moving to the client side, we do allow some of the properties to be populated by the client itself, like the username, password, user's first name, last name, address. All that information should be something that the user should be able to have the client send to the server automatically. However, there are some properties that the user should not be able to define, like what their role is. That should be something that the server should determine what the role is. So if an application is vulnerable to mass assignment, it's possible for a bad guy to modify a legit request and add additional parameters to that request. So for example, in this case, this is a legit request. It requires only username and password. What if the bad guy was to add role admin over here? If it was vulnerable to mass assignment, this particular user would be given admin access. So the question may come up, how do we know that there's such a property that exists? So that is very easy to find. All an attacker needs to do is capture a lot of traffic going back and forth between the client and server, and identify any GET request that has that property exposed. So this is a real world example, New Relic. It's a cloud-based software to help websites and application owners do analytics on how the performance of their application is. So free tier users are not allowed API access. However, the restriction can very easily be bypassed by intercepting a request. So all the bad guy would have to do is to the request just add account, allow API access equals true. Now you have API access, you don't need to pay for it. So preventing mass assignment. Whitelist the properties that the client should be able to update. Avoid using functions that automatically bind the properties to the code. That should never happen. We should never have anything sent by the client be directly populated into the code. Next is security misconfiguration. This is one of my favorite topics, so I'll go on a tangent there. And that is because there's so many different ways where this can go wrong. So security misconfiguration is commonly a result of insecure default configurations. Some of the examples are patching issues. So if you don't patch your systems, that is a security misconfiguration issue. So in this case, we can see on the response, you're seeing that we are using Glassfish Server Open Source Edition 4.1.2. Why could this be a problem? Because this might have a known vulnerability out there, and a bad guy can Google or go to a vulnerability database and identify what those vulnerabilities are. If the system is not patched for those vulnerabilities, the bad guy would next try to exploit that vulnerability and potentially breach your system. Misconfigure TLS. It is also very easy to mess up TLS, and that is because we have, in the industry, we have so many different types of legacy systems. So basically, TLS misconfigurations is of two main types. Either you're using an outdated protocol or you're using an outdated cipher. TLS 1.3 is coming up. So not every system will be able to support TLS 1.3, especially if you have a lot of legacy systems on your, in your environment. So what we should do is we should have the most secure version that our environment would support. Missing security headers. So a lot of these web applications allow the server to, yes, question?
What is TLS?
TLS is transport layer security. So are you familiar with SSL? Okay, so SSL is secure socket layer?
Yep.
Okay, you put me on the spot. Okay, so SSL, we had version 1, 2, and 3, and after 3, then came TLS 1.0, TLS 1.1, 1.2, and 1.3, right here. So, any other questions on that?
It's used to encrypt the traffic between, when you're on a computer, say HTTPS, that means all your traffic is encrypted going to the server, so not anybody can just listen in on your traffic.
Transport layer security, so it protects this data in transit. Thank you, Xavier. Yeah. So missing security headers. Your server can set security headers to protect your applications against some of the common attacks. So here we have some of the security headers that are missing. For example, extreme options. It can be if your server sets that your application is not prone to clickjacking. So it's good to leverage these security headers whenever possible. Verbose error messages. There's a lot of different flavors of this misconfiguration. In this case, we are seeing that something happened, the application was not able to process the request that was sent, and then they gave the whole stack trace to the user. Now what could happen is if an attacker is really, really smart, that attacker can try to understand exactly what went wrong and try to pivot their attack to bypass this problem. So don't give attackers more information than they need to. Another flavor of verbose error messages is when we display HTTP responses as part of the error message. So for example, let's say you try to access a resource and the web server comes back with 401 unauthorized. What does that tell a bad guy? Any guesses? Was that?
Some sort of key or passkey.
Yes.
It says that the file exists, but you don't have access to it?
Exactly right. So that does tell the attacker that there is a file and they can now try to either modify their way of getting to that file or try to brute force and provide some sort of authentication to get to that file. So again, don't provide more information to the user than is needed. And we'll talk about how to prevent that in just a second. Default pages and directories. A lot of our systems, they come with default pages, directories, just to help manuals and all that stuff. When you're rolling out an application, just make sure that you remove all the unnecessary default pages and directories because they could contain vulnerable code themselves. And secondly, if I'm a user and I see default pages on an application, I think they're not doing their security due diligence. So this is something, if it's not needed, then don't roll it out to production. So real world example, has anybody heard of the Capital One hack that recently happened? Good, yeah, it happened last year. More than 100 million credit card applications were stolen. It was caused because of misconfigured web application firewall. And basically the web application firewall was configured with too many permissions, and this allowed the listing of files in any buckets of data and all the contents of those files. So basically all of that data was exposed. The WAF, web application firewall, was tricked into running commands that it should not have been allowed to. So the WAF was misconfigured in the first place. So how do we prevent security misconfiguration? Keep your systems patched. Make sure you remove all the default configurations, remove default accounts, update TLS configurations, use the most secure protocol and the most secure